Students, in this video we're going to cover Unit 1, Lesson 6, writing and solving two-step equations. So I left my book at school. So I printed these pages, just realized it doesn't give page numbers. Hold tight. Okay, page 31. Sorry, I had to go dig for it real quick. All right, so standard for this is we're going to write and solve two-step equations with one variable with mathematical or real-world context where all the terms are rational numbers. Learning targets, you guys are going to be able to solve two-step equations with a mathematical or real-world context, and you're going to be able to write a two-step equation given a real-world context. So this will look a little different. Like I said, I printed this. This may actually work easier in class, but we'll see. All right, so, and it printed very strangely. So like I said, it doesn't look like the book. You guys will see the warm up, which I don't do on the videos. This is more of a, for this one, you're looking at, it's 100 paper clips, and 4 of them are clipped together, and you're supposed to estimate how long it would take you to chain together 100 of those, and then try to guesstimate a low number, a high number, or just right. Like I said, you guys are welcome to do that on your own. Flip over to guided practice. So 1.6.2, properties of equality. And this was really difficult to try to explain, because it looks better with letters than it does with numbers. I'll try to do a better job with it on here. So the symmetric property. So if A equals B, then B equals A. Let's see. And the only way I know how to write it would be like, so if A equals B and B equals A, 3A equals 3B, and 3B equals 3A. It's the way I described it in class is if two students each have $5, student A or student B, they both have the same amount of money, regardless of how you wrote it. That's kind of what this is. So addition property. All right, so if A equals B, then A plus C equals B plus C. So this would be, I guess A plus 2 would equal 2 plus A. You could also look at it like, but it'd have to be something like this too. So A plus 2 is equal to 2 plus B if A equals B. Again, I know this is kind of weird. Same here. Um, if A and B are equal, you subtract the same number, that's going to be the same. So, like A minus 3 would equal B minus 3. Same here with multiplication. So I think I kind of did that up here with inadvertently. So 3A equals 3B if A equals B. Or AC would be equal to BC. And then division works the same way, but C can't equal 0. This would be like A over 3 is equal to B over 3. So it's kind of hard to, oops, sorry, didn't realize we were off the page again. This will make a little more sense here. So, and sorry, again, it's cut off. I doctored it. I'm more of a math teacher than a tech guy, so I apologize. All right, so what property justifies the equation 4m plus 7.1 is equal to 24.38 is equivalent to 24.38 equals 4m plus 7 4m plus 7.1, and that's going to be your addition property. So this is what it looks like. So 4m plus 7.1 equals 24.38, and 24.38 is also equal to 4m plus 7.1. So backwards or forwards, it's the same thing. All right, so down here we're going to solve this equation using the applying the properties of equality. I'll scoot this down. It cuts off at the bottom of the page. Let me just flip over real quick and see. Yeah, we'll make it work. Actually, we're substituting this in, so we'll just flip it over when we get there. So, number 3, solve negative 8.1 equals z over z divided by negative 3 minus 2/5. So fill in each box with an operation. Oh, an operation. See, oh well, and there's a box that you can't even see the box on the print. But, so right here we're trying to get z by itself. We have the negative 2.5. So we need to add that to both sides to get, in our effort to get z alone. So we would go plus 2/5 plus 2/5. I like to write it going vertically, but it's the same thing. So negative 2.2/5 plus 2/5, so these cancel. So all you're left with over here is z divided by negative 3. And remember, 2/5 is the same as, so let's just put this, fifths equals 0.4. Oops. I'm just going to set this over here. So when we're doing this, we got negative 8.1 plus 0.4, and what we end up with is negative 7.7. So on this side, once we've added these two, we have negative 7.7, and it equals z divided by 3. All right, so if we're dividing, we have to do the inverse operation to get rid of the negative 3, so we're going to multiply. So multiplying both sides, I'm going to put it next to it because if it's touching, it is multiplying. And I'm going to write it like this. Now, this is invisible math. We know that negative 3 is the same as negative 3 over 1. But I'm going to do this. I got a purpose, I promise. I'm just going to write negative 3 over here. Same thing, but I'm doing this so we know it's the same thing. All right, so negative 3 goes into negative 3 one time. So z times 1 is just z. So we're going to take this up here. And remember, z divided by negative 3 equals 7.7 is the same as, or we write it either way. So the z is going over here. That's all that's left, because z over 1 is the same as z, right? Now over here, negative 3 times 7.7 is negative, let me just, oops. Times, okay, so negative 7.7 times negative 3 gives us 23.1. So z equals 23.1. So part B is asking us, use substitution to verify the solution. So what you're going to do is plug in 23.1 for z. So I flipped this over, unfortunately. But at the top here, bring the papers with me. So this is negative 8.1 equals, all right, so we're substituting, this was z, remember, and we found that z was 23.1. So we're substituting that in. So 23.1. Sorry, I forgot my calculator too. Divided by negative 3. So that equals 7.7. I think we saw that number before, right? minus 2/5. So just to prove it to you, 2 divided by 5, or 2/5, is 0.4. That's negative. And we're adding it, or yeah, adding two negative numbers. Negative 2/5, or 0.4, and negative 7.7. And you see how it equals negative 8.1. Both sides of our equation have to be the same, and they are. So that means we are correct. So we plug it back in. And this must be mixed up with another page because that's a different problem. Okay, well, we'll find it somewhere when I said it printed very strangely. So there may be another problem at the bottom. If there is, you know what, I think it is this one. I think it cut off because here was the X. So yeah, so the next problem is this problem. And first they want us to solve, and then they want us to plug it in. So notice we have 5x plus 4.25 equals negative 3 1/4. So you know that 1/4 is also 0.25. So I'm going to change this to a decimal over here. So 3 1/4 is the same as 3 1/4. Okay, everybody with me? So now we want to get x by itself. So we're going to subtract the 4.25 from both sides. Just going to show this is an arrow because we took that down. All right, so positive 4.25 and negative 4.25 cancel out. So 5x, we didn't mess with it, so it comes down. Our equal sign is in the middle. That's where we draw our line. And over here we have negative 3 1/4, or negative 3.25, and minus 4.25. And that was negative 7.5. All right, we still want x by itself. So divide both sides by 5. You can do it separate or draw a line like that, but these 5's cancel. X is by itself, it comes down, our equal sign comes down. Negative 7.5 divided by 5 equals negative 1.5. And then it says to substitute like we did for the last problem, so let's rewrite it. Except this time, where x is, I'm going to write negative 1.5 because we just found that and we're plugging it in, or substituting, so that we can verify our solution. So there's our equation. We replaced x with negative 1.5. So 5 times 1.5 negative, so negative 7.5. We saw that a second ago. So negative 7.5 plus the 4.25 that we had in the equation gives us negative 3.25, which is also negative 3 1/4. They both equal, so we verify our solution. Okay. Flipping the page, hopefully. I'm scared now that what else got lost. Okay, so in class, we did this section today. And I did the first two problems. I assigned you guys the other two. Some of you did this in class. Some of you took the book home. So I'm not going to do these two. I'm going to leave these and check you guys tomorrow and see how we did. Um, so let's. So we're gonna solve each equation using the properties of equality. And so let's go over here. So negative 4w minus 7 equals negative 11.2. So we want this guy by itself. I'm going to circle the variables. First thing I do is I start with the number that's by itself. So not the coefficient with the variable, just this guy. So minus 7, we're going to do the opposite, so we're going to add 7 to both sides. My line where my equal sign is, negative 7 and positive 7 cancel out. There's 0. We're not going to write 0, we just know that it's the only thing left now is the negative 4w. So we'll bring him down because we haven't touched him. Now over here, we got to do some math. 11.2, negative 11.2 plus 7 is negative, remember the equal sign is where that line is, negative 4.2. All right, so when they're touching, they're multiplying, so we got to divide both sides by negative 4 so we can get w by itself. So the negative 4's cancel. We're left with w. There's our equal sign. And negative 4.2 divided by negative 4 gives us 1.05. So let's plug it back in, or substitute, excuse me. So negative 4 1.05 minus 7 equals negative 11.2. So we're going to multiply our negative 4 times 1.05. We got negative 4.2 minus 7, negative 11.2. So now we're going to subtract 7 from that, and we got negative 11.2. The other side is negative 11.2, so that checks out. We're good to go. All right, so let's look over here on the right. Like I said, the bottom two, these are yours. This one's going to work. These are both going to work. Well, this is going to work like this, and this is going to work similar to that. Excuse me. Okay, so we got g divided by 8 plus 1/2 equals 0. Well, let's get rid of the 1/2 because we got to get g by itself. All right, so the halves cancel. Over here, it's g divided by 8. It equals negative half because 0 minus a half is negative a half. All right, so g divided by 8 equals negative 1/2. If this is dividing, so we need to multiply. And again, I'm going to write it 8 over 1. I'm not going to do this forever, just for the first little bit. So these are going to cancel here. So you're just left with g, because the rest is 1s. And if you take, so you know that 1/2 is the same as 0.5. I'm not going to try to prove it to you. I hope, hopefully you believe that. Otherwise, I don't know. Anyway, so multiply by 8. So g equals negative 4. Let's prove it. So the top of my so where g was, it's going to be negative 4, and it's divided by 8 plus 1/2, and it's going to equal 0. Well, we know that negative 4 over 8 reduces to negative 1/2, plus 1/2 is equal to 0. Well, these guys equal 0, so we're good. Hopefully I didn't lose you. So work on these two, and flip the page over. This is something that I didn't think of this before. So method 1, you can apply the distributive property. Method 2, you're going to divide both sides by the factor being distributed. So that's this 3. So over here, so 3 would go to the 6, and then it would go to the negative p. 63 comes down. 3 times 6 is 18. 3 times negative p is negative 3p. All right, over here, instead of distributing, we're going to divide both sides by 3. So over here, these 3's cancel out. So you're left with 6 minus p, and then 63 divided by 3 is 21. So let's solve and see if we get the same thing. So I'm going to subtract 6 from both sides. I'm still trying to get p by itself. 6 minus 6 is 0, so they cancel. 21 minus 6 is 15. So negative p equals 15. That means p equals negative 15. See, I just moved the sign over. One has a sign, the negative sign, one does not. So if you multiply both sides by negative 1, this becomes positive p, this becomes negative 15. That's all I did. I just did it without showing the math. So p equals negative 15 over here. Let's see what happens on this guy. So this side, we're going to subtract the 18. 18 minus 18 is 0, so we're left with negative 3p, and it equals 63 minus 18 is 45. Divide both sides by negative 3. The negative 3's cancel, you're left with p equals negative 15. See how these match. So we got the same answer, we just got it two different ways. And now that we've seen this, you guys are welcome to do either one of these. Verify the solution. So 63 equals 3 times 6 minus, so minus p, so minus negative 15. Because p equals negative 15, right? And two negatives make a positive, right? So 6 plus 15, see, two negatives make a positive. And 6 plus 15 is 21. The 3, we haven't touched him, he comes down. 63 hasn't touched, it comes down. Oops, sorry, off the screen again, my bad. 3 comes down, 63 comes down. Two negatives make a positive. So now we got 3 times 21 equals 63. Well, I'm sure you already know this by now, but 21 times 3 equals 63. So that means we have 63 here, and we have a check mark. So we're good to go. Excuse me. Okay, flip that over. So next page. Let's see. Yeah, this scares me because I don't. Hold on a minute. Let's see. All right, actually. Okay. Well, all right, we'll make it quick. All right, so 1.6.5, writing a two-step equation from a real-world context. So when writing equations to represent real-world context, it is helpful to start by considering the known and unknown quantities involved in the situation. So Darius is draining his pool for resurfacing. The pool began with 13,650 gallons of water, and it is draining at a rate of 640 gallons per hour. How long will it take the pool? How long has the pool been draining if there are 9,330 gallons currently in the pool? Complete the table and describe the known and unknown quantities of the situation. All right, so we know that so the pool started with 13,650 gallons and drains at 640 gallons per hour, and it's been draining, or it's currently at 9,330 gallons. Unknown. So we don't know how long it's been draining. But we know how fast and we know where it's at. So, sorry, I didn't realize I was off the page again. I was just writing away. All right, with your partner, discuss the quantities related to this situation. Summarize your discussion. So, yeah, I realized we didn't get to this in class. That's why I was a little confused. So I'm going to stop there. Let me see. Yeah, actually, yeah, I'll finish this because we'll do this in class, and then this next section here, 1.6.6, this is some stuff you guys are going to work together. And then the wrap up I'm going to save for in class as well. So, your partner discusses the quantities that are related. So really what you're going to do is you're going to take the total and you're going to subtract what they currently have. So hang on. Okay, so I'm off the page again. God, sorry. So 13,650 minus the 9330. Oops. See, I messed that up. So 4,320 gallons have drained. If we know that it drains at 640 gallons per hour, we can calculate that it's been draining for 6.75 hours. So 4,320 gallons at 640 gallons per hour equal 6.75 hours. So let me flip this over. So yeah, I will actually leave off there, and in class I will show you guys what we're going to have for the actual algebraic expression. So 1.6.6, you guys work, there's equation A and B, and then there's a couple of questions below that, and like I said, the wrap up we will do in the morning in class. Double check the back page, nothing there. Okay, sorry about that. It was a little different working this way. I apologize for the miscommunication along the way. So if you have any questions, please let me know, Parent Square, or you can send me an email, or you can comment to the video. Please consider liking and subscribing because it'll help the channel. Until next time, have a good night.